Before proving this theorem, we must know what are angles in alternate segment. Consider this circle with center C and these points P, Q, R and S on the circumference of the circle, and let T, P, T dash, T, and this point is P and T dash be the tangent of this circle. Then the segment formed by this arc RSP, the segment formed by this arc RSP is called alternate segment to the angle RPT. This segment is the alternate segment for the angle RPT, and also this angle RSP is called angle in alternate segment for angle RPT. Now coming back to this theorem, if a line touches a circle at say point P, and from the point of contact P a chord is drawn PR, then the angles between the tangent and the chord, this angle, are respectively equal to the angles in the corresponding alternate segment. That means we have to prove that angle RPT is equal to angle in alternate segment, which is RSP, and also for the angle RPT dash, this angle is equal to angle in alternate segment for this angle, which is, say, let this point be Q, then RPT dash is equal to RQP. This we have to prove, that this angle is equal to this angle, and secondly T dash PR, this angle is equal to RQP. Now for this, first let C be the center of the circle. Join this center to the point P and extend PC to A, and also join AR. Now consider this triangle ARP, and in this triangle we know that ACP is diameter of the circle. Therefore this angle ARP, we know that angle in semicircle, angle ARP will be 90 degree, because we know that angle in semicircle is of 90 degree. Now suppose this angle is theta. Angle RAP, let angle RAP is equal to theta, then by sum angle property we know that sum of this angle A plus APR must be 180 degree. Therefore this angle APR will be 90 minus theta. Now CP we know is radius of the circle. This line CP is radius of the circle, and we already know that angle between radius and tangent at point of contact is 90 degree. Therefore angle CPT will be 90 degree, because CP is radius and T dash PT or PT is tangent. So at the point of contact, this angle CPT will be 90 degree. And we have already proved that CPR is 90 minus theta. CPR or APR is one and the same thing. It is 90 minus theta. This angle is 90 minus theta. Therefore angle RPT is actually equal to angle CPT, this angle, minus CPR, angle CPR. So this will be CPT is 90 degree and CPR is 90 minus theta, which comes out to be negative, negative, positive is theta. So what we have proved that RPT, this angle is equal to theta. So from 1 and 2, we observe that from 1 and 2 that RAP is theta, this is theta, and RPT, this angle is also theta. Okay, angle RAP is equal to angle RPT. Now consider these two angles, RAP and RSP. Angle RAP is equal to angle RSP. Why? Because these two angles are angles subtended by the chord RP in the same segment of the circle, and we know that angles in the same segment are equal. So these two are equal. So if this is theta, this angle is also theta. So from these two, we conclude that RAP is equal to RPT and RAP is also equal to angle RSP. So this implies angle RPT is equal to angle RSP. Thus this first part is proved. RPT is equal to RSP. Now what about this angle RPT dash? This angle RPT dash, for second part, angle RPT dash will be 180 minus RPT, because they form a linear pair. T dash PT is a straight line, and also this angle SRP, also angle SRP is 180 minus RSP, because these are opposite angles of a cyclic quadrilateral. SRQP is a cyclic quadrilateral. Therefore, this should be RSP. This is RQP. This angle is actually angle RQP. This angle. This angle is equal to 180 minus this angle, because these are opposite angles of cyclic quadrilateral. So from this and this, we know that RPT and RSP, this we have already proved. So if RPT is equal to RSP, then from this and this, RPT is equal to RSP, we have already proved. It implies 180 minus RPT is equal to 180 minus RSP. But 180 minus RPT is angle RPT dash, and 180 minus RSP is angle RQP. So second part is proved, that angle RPT dash is equal to R